Oh boy, I'm super excited today. Browsing OpenRouter, I happen to see that Qwen Turbo, Qwen Plus, and Qwen Max are now available for testing. Qwen Turbo, I do not expect to win if I put it head to head against Max, but I do want to see how well it performs. In coding, I do want to test this a little bit more too because it claims a 1 million context window. That is absolutely insane. But you can have a big context window and it not have it actually help the model. So I do want to test that probably in a future video. And then we have the Qwen Max, which is the big boy model for Qwen. It is basically kind of the Deep 3 V3 competitor. So this article that was released on January 28th, 2025, Qwen 2.5 Max, exploring the intelligence of large-scale MOE model. A few things to note here is if you look at this in particular benchmark set here. The red bar is Qwen 2.5 Max. So it claims a win in Arena Hard against DeepSeek V3, Llama 3.1405, GPT 4.0806, and Claude 3.5 Sonnet. MMLU Pro, it's pretty close, right in line with everything else I'd say. GPQA Diamond, Claude wins that one, but it's second in that group. Pretty close on live code benchmark, just slightly behind Claude here. And in the live bench, it's actually the winner in that category by a couple points. Qwen 2.5 Max outperforms DeepSeek V3 in benchmarks such as Arena Hard Live Benchmark, Live Code Bench, and GPQA Diamond. I will say I've tested it pretty well in the UI online. So you can go to chat.qwenlm.ai and you'll see the Qwen 2.5 Max model that you're able to use there. Now, let me jump into the Turbo model real quick. The big thing I care about with this model is the 1 million tokens. I think that's incredible, but also I really do like just testing new models. So the three things here, longer context support, we talked about that. 1 million English words or 1.5 million Chinese characters. The model achieves 100% accuracy in the 1 millionth length passkey retrieval task and scores 93.1 on the long text evaluation benchmark ruler. That seems incredible. Faster inference speed and then lower cost. And to talk a little bit about cost, we can kind of see the cost here on OpenRouter. So we've got 40 cents per million input tokens and $1.20 per million output tokens for Qwen Plus, which is right in the middle. And you can see how cheap the Turbo model is. 5 cents per million input tokens, 20 cents per million output tokens. And on the Qwen Max, it's actually fairly expensive, $1.6 per million input and $6.40 per million output. And I have actually already been testing this quite a bit, as you can kind of see in my activity that I have here. Now, let's jump into the model competition now that we have a little bit of context on what these models are. So I've actually updated this a bit. I have found that my tests in the last one were actually too simplified. I've actually pushed for some that I'm expecting to fail, but my goal is to actually see how close they can actually get. This first one is the same as my other one, which is a maze solver using the breadth first search and have it visualized. Qwen 2.5, each of them have their temperature set to 0.1 in the API call, keeping it low. I tried to actually determine if there'd be much of a difference, but I know for coding, you just want that lower regardless. And both of them seem to be performing too well in my initial test. The other thing I'll caveat is if you go into OpenRouter and look who's actually providing the endpoint for this, it's Alibaba. And that endpoint constantly is giving me basically reaching my quota. I think they have it throttled incredibly hard. So this took me a lot longer than I would like to actually put together. Because in testing to make sure everything was working well, it kept timing me out and erroring me out. So if that happens in this, I'll cut that part out, but I will have to probably rerun this a few times just to get the model work. So can you use it in real code? Yes, I have, but that stupid limit that they put on there is a killer right now. And I just have to assume that is because they're just getting overwhelmed by everything that's going on. So we're going to start by loading in this very first solution by Qwen 2.5 Max into our Visual Studio Code here. Here we go. This is Qwen 2.5 Max, which is the big model. I'm expecting a really good result here. And that is an incredible result, to be honest with you. It's finding its way directly through the maze, and boom, no path found. And that is probably because, yep, it set the endpoint to 8.8 and then the start point to 1.1. So I'm assuming this starts with 0 here, as the endpoint's probably something there. But that pathfinding was just absolutely spot on there. Really, really, really good. You could see the breadth first search in action absolutely perfectly there. Now we're going to compare that to the turbo version, which doesn't really have anything going on. That is unfortunate. I was expecting it to be a little bit more something there. You can see here how it actually specified the maze. They have the start point up here potentially with, I don't know why they showed it black. Just overall, this is unfortunate. So we're going to give 1 win over to the 2.5 Max model, but you can see that both actually had pretty reasonable output there. So we're going to go ahead and vote for Model A. Now, the next question is one that we also did in the other one, which is another one. It's a maze solver with the A-star search. And if you don't know what the A-star search is, it's a pathfinding algorithm that was really popular and probably still is. I've been out of the video game industry for a while now, but it was incredibly popular in the video game industry, and you would use it for really perform at pathfinding. So here we go. This is the Big Daddy. Whoa, look at this. Very, very cool. I wish it would indicate where it was starting and going. I'm wondering if where the end is here. Yeah, there it goes. Okay, it drew the path. So it actually probably put a delay. I'd have to look at the code, but I bet you, yeah, look at that. It put a delay in there to render it. Otherwise, it would have been instantaneous pathfinding. That's exactly the way A-star works. And it ended up finding the quickest path. Just absolutely solid. Very solid there. Oh, I actually did not mean to vote for that. That is my bad. So let me go back here. We're gonna know Qwen 2.5 actually wins this pretty well. So we're gonna go ahead and grab the turbo one. I just want to see if we can get a working version out of the turbo version. I don't even know what's going on here, but let's see. Is there anything interactable? There's I guess they have a quit button that you can hit. Yeah, it's unfortunate. Again, just an absolute another fail for turbo. So I don't think the turbo model is actually going to be very good for coding. So I've already voted, but anyway. The next one we have is the Sudoku solver. I actually have high hopes on the turbo one this time. So let's go ahead and start with the Qwen 2.5 Max version here. Go into question 3. And the Max version. Whoa, okay, so this is the first time I've got a result like this before, where it gave me an empty board. Can I, like, type in... I can. Let's see, what if I did that? Wow, that is absolutely amazing. So you could be working on a Sudoku board, like and actually type in anything you want. This is, when I wrote this prompt, this is what I wanted it to do, but all of them were already pre-generating a board for me. So really, really, really interesting. And I don't think there's a way, like, what if I typed a 3 there? Yep, it catches the invalid stuff there. All right, that is a huge win there. Now, let's go into turbo. Code looks about the same length, slightly shorter. The explanation is relatively similar. Actually, the Max one goes into a little bit more detail there, so that's pretty cool. Let's go ahead and run the turbo version. What is this? Can I resize that? No. Oh, I can slightly. Let me hit solve. What happened? That is the most weirdest thing ever. Can I? Okay, so it's just formatted poorly. Can I type stuff in? Yeah, I have to give it to the other one just because purely out of formatting. So 3.0. So you can see the turbo model is not doing very well at code. I have had a little bit of luck with it, but I just don't think it's a model that's built for that. So anyway, you can see here, I ended up getting that error from Alibaba because I hit their quota. I'm going to go ahead and go to the next one here because we did finish that last one off. and we're going to do the Connect 4 game with AI graphical interface. So we're going to grab the Max version first, and that is a lot of code. I have high hopes. Again, I have, in all the ones I've tested, I haven't tested many big models, but I tested like DeepSeek V3, and it was close but not perfect. But a lot of them end up failing on this query here. So let's see if we can get lucky. Well, okay, so I like this board. We have a 7x7 board. Oh, and it crashes. It was so close. You could even see it fall down to the bottom. That is so unfortunate. Okay. I'm actually very disappointed on that. Now let's see what the turbo model does. The turbo model actually has more code here. Very, very surprising. If this one works and the other one doesn't, I'm going to be kind of blown away. I've got some weird like flickering. Okay, so that one also crashes. The piece didn't fall. Oh, that's unfortunate. It's a failure on both of them. So we'll vote for a tie there and just go to the next one. This is the one, if you watched the video I did a little while ago where I wanted to see if some of the models could actually create a pool simulation, a pool game simulation. This is the prompt I ended up using. I wanted to start testing that as part of my test suite here. So here we go. We're going to run this model, which is the max one first. Oh, did you see that? It actually just got the error. I got to fix that bug in my app because what ends up happening is the error comes in and then it throws up and then it messes with everything. Okay, so this is the max version. Whoa, the physics actually look great. It did not hit the wall though. No wall collision. The ball-to-ball collision's like excellent. Okay, maybe it's just, I don't know how to actually. Okay, well, let's go ahead and rerun this and then I'll come back after it's done. Okay, so now I have the turbo version. I'm gonna go ahead and grab this before I get an error here. Hopefully I can beat that out. And we're gonna go ahead and run that. It's question 5 here. And I am not even sure what it's trying to create here. But that is quite hilarious. The output. Nothing's able to be moved from what I can tell. Let me see. Sometimes the arrows will do something. Nope. Okay. Clear winner on the max version. So we know this one is the winner here. Man, that quota that they give us is just so brutal. Part of the problem is I'm trying to like feed ahead and then that ends up causing me issues. Okay, so let's go ahead and grab this one. This is the game of Snake. Everyone probably is so used to seeing tests on this one. If you have an idea for one that I could replace this with, I'd be totally game for it. I'm excited to show you some of the new ones that I've came up with, but the game of Snake is just kind of a classic one that AI seemed to starting to get like really, really good at. Well, that is crazy fast. Okay. That is incredibly fast. Can I even pick up the food? Yeah. So 10 points each. Yeah, this is working well. I can't turn back on myself, which is I think okay. I actually prefer that version, to be honest. When you can't go like left and then right and kill yourself by going directly in it. The speed of this is absolutely insane. For a lot of them are slow and bigger boards. All right, we're going to call that as a successful test for Qwen Max. And then let's go ahead and grab the turbo version here. Do the same thing. I'm expecting this to also work. This is more like what I'm used to seeing, to be honest. Is like these little dots on these like giant screens. Each food counts as a point. I can turn back in on myself. I don't know. I'd just call both of these as kind of successful. This has become. I've had a few comments now where this is just too easy of a test, I think. So I would like to replace this one at some point with something a little bit harder. So for this one, we'll vote for a tie. I've already messed up this, so I'm not even going to worry about voting at this point. We kind of know where things lie. All right, so this one is a top-down shooter game. I do not know how any of these are going to perform. This is a new one that I've been testing, and I've got a little bit. I wanted to keep it a vague prompt, but I also wanted to see if it could actually generate something here. The turbo model, I'm not expecting it to be able to do much, but if I can actually get a reasonable top-down shooter, I will be incredibly excited. Let's go to question 7 here. Whoa. Oops. I bet you I have to move. I don't know how to move. Oh, WASD. How do I shoot? I wonder if it tells me how to shoot. Oh, space bar. All right, all right. Let's try it again. Oh, I have to tap space bar. Oh, it aims where my mouse is. Holy cow, that's actually pretty cool. Hard. I would rather it be like a mouse button click or something. I wonder if that's like a power up in there, that green thing. It is. Some sort of... Wow, do you see all those enemies spotted? I'm actually very impressed with that one. I was not expecting it to be that playable. I had to look at the code a little bit to figure out the keys. Let's take a look and see what Turbo comes up with. I'm not expecting it to be that good, but I'm still excited to see the results. It'd be neat if it actually can run. Oh no, that's unfortunate. So we have basically a local variable running. It's not associated with data there. I've been doing a lot of TypeScript today. So let's try this again. All right, no movement. My score's going up. So I'm definitely good at winning this game. Probably the best at the game. So I do give points for this game for letting me feel like I accomplished something, but I can do nothing, it seems. Wait, actually I'm looking. It looks like I use the arrow keys to move. Can I like go pick that up? What does that do? I can. No enemies. Let me take a look at what other key buttons they have. So they have up, down, left, right. Yep, I don't know. I don't know if that's like an enemy or... Maybe I don't shoot. I'm just like supposed to run into the enemies. Yeah, I think it's pretty clear the max one's for sure better there. So let's go to the next problem. All right, this is another one that I'm excited about. This one, I have found, fascinatingly enough, that the big models usually do worse on this problem. And I don't understand that. If that happens here again, I'm just going to be so baffled. We should not see any linear, like, lines. Basically, there should be sort of, should be like a gradient, like with some curves around them. You'll see if it actually gets it right. I'll explain it a little bit more. But this particular problem, before I actually go run it, is the neural network XOR problem with visualization. Basically, I need to create an application that builds and trains a simple neural network. So you should actually see the epochs running down in the log, if that's working correctly, if it logs it, with high-level libraries to solve the XOR problem. This is like the simplest thing to actually train a neural network on. The program should include a visual representation of the training process, such as plotting the loss over iterations or displaying decision boundaries. Now, I think I need to change this prompt a little bit, because I think what's ended up happening is the models are like displaying different things, and it doesn't really tell you what it's displaying. I think I'm going to have to like really be very specific on that. But anyway, let's take a look at what the max version does here. Oh, you saw the epoch. Oh my God. Wow, really? Interesting. The training loss thing is great. I don't quite follow what this graph is trying to do here. I haven't seen one come out with this sort of detail. To me, this feels wrong. Typically, you'd actually see like them looping around like this. You know, let me see if I can actually draw a line here for a second. So typically, you'd see them like I'm terrible at drawing. You'd see something like this, and then something like this, and there'd be some gradients between here, and this, like that. This is what you'd ideally want to see. And this isn't perfect, but you can kind of get the idea. But this is kind of interesting because you can see the loss down through here, and it went from 0.255 to 0.234 at epoch 10,000. So pretty good, but definitely not perfect. Again, the big models just do not get the visualization of that correct. Let's take a look at the turbo version now. I'm going to pull that in here. Yeah, this is a lot better, but I'm not really sure. Error. Epoch. I wonder why that didn't do training loss. It's cool though. It's still cool that it showed the error rate. See, these seem right to me. You know, this seems pretty good. This seems pretty good. I'm not totally sure. I can't remember. And I'm trying to think about it right now. You can kind of see a little bit of curve here, but I thought this one should be curved a little bit more too than it is. But it's definitely a better representation than the other one by far, from what I've seen in this type of model here. So I think we'll give that win to the Qwen 2.5 Turbo, even though I don't think either one of them was absolutely perfect. Let's go over and do this one. This is one I'm actually pretty excited to see what they come up with. So one of the very first neural networks I built was a handwriting recognition one. I don't know what it's going to come up with, but I was like, can it give me like a tool where I can actually write in it to help it train a neural network? So I'm very curious if this is going to work properly. And I may need to start tuning the prompt on this one a bit more because it's a fairly complex problem. But I am super curious. I've tested this a few times already and got really interesting results with other models. I have not tested it with this particular model, so I'm curious if it even runs here. So we're running. This may take a few seconds because it's training something. More than likely if it's actually working. I already do see a problem here though, because image draw is not defined. That's unfortunate. Image draw. And one hot encoder apparently. Sparse actually. And one hot encoder wasn't supposed to be there. Okay, that's unfortunate. I've actually had some functional ones, but this is a failure. I'd have to spend some time trying to get that one working. That'd be really cool to actually see what that could do though. This one doesn't seem like near enough code to actually do anything, so I don't even expect this to do much. But let's take a look. Sometimes they surprise me. No, we ended up getting the TensorFlow error, which means I do need to just install it. All right, now I'm actually running it after setting TensorFlow. I'm actually surprised I didn't have TensorFlow already installed in this environment, but that's probably because I mainly use it in WSL, my WSL environment. So here we go. We've got a couple, looks like warnings here. You may see slightly different numerical results due to floating point round-off errors from different computational orders. To turn them off, set the environment variable. Dang it. Okay. We ended up with another error. NumPy has no attribute int. Okay. That's a bummer. Both of those are a failure. So let's go ahead to the next question here. And the final question. Traffic simulation with real-time visualization. I want to simulate city traffic on a grid of roads, complete with traffic lights, vehicle dynamics, and congestion patterns. Visualize how changing light patterns or road conditions affect overall traffic flow. So again, this is a very hard one, but I'm doing this on purpose because some of the models I'm testing are extremely good. So I'm trying to crank up the difficulty a little bit so it's not just always success. I do not see enough code here in my personal opinion. Maybe I'm wrong. for the Max one, but let's take a look. This one may surprise me. Okay, let's take a look. I definitely do not want to open that. What is happening? Oh, I see. It's definitely bizarre. Is it like red light, green light, and the boxes are cars driving? So they're navigating around. They're moving, and then they stop when it's a red light. They do. I mean, I guess it's funny they let me do the cycle time there. I don't know. I wasn't sure what to actually expect from Qwen, but it tried to do something with red light, green light, and understood traffic lights a bit. It didn't do what I was hoping though, which would be like actual like traffic moving down streets. But I'm betting models will eventually get there. And last but not least, we're gonna do the turbo model. Oh, interesting. So they've got like moving vehicles, but I don't think the lights are actually working. I bet you those are supposed to be traffic lights because it's got like the red, green, or I guess it's top, bottom. Um, so I think it got a little bit more of the understanding of the traffic movement that I wanted to do, but it did less of the actual simulation. It just got two cars moving in opposite directions. So where does that leave me? I would love to know what you guys' thoughts are on Qwen 2.5 Max. I'm going to be honest, the API limitations has made it very hard for me to test this anywhere else other than very slow. Like in that program that I just showed you, it works because I can just refresh when it fails. But in root code, when I use it and it works really good. But then it'll error and error and error, and it's so frustrating. I just can't work like that. I got to get too much stuff done during the day. If though they end up getting it to where I actually can have more throughput, I'm willing to pay those token costs if they give it to me to actually really test it in a production application to see how it works. It's very impressed with some of the applications it came up with. I think it did probably the best I've seen on the Connect 4, even though it did crash. You could see the piece fall to the bottom, which hadn't really happened before. And I bet you if I ran it again, I could eventually get one that actually works. It's probably just that random variance that you slightly get into those models. The turbo model, on the other hand, not useful for coding, so I guess we know that going into it, but it seems like it would be interesting for things that need a lot of context. And they did say simple tasks, so I'm probably going to try to put that into some of my agent frameworks that I have to see how that actually performs as an agent model. But again, I can't really do that until the API doesn't fail on me every second time I run it. But that's it for today. Let me know your thoughts, and if you like content like this, I would love it if you like and subscribe. It means the world to me. Just hit 3K subscribers, which is absolutely awesome. So keep giving me feedback. I would love to know other things that you would want me to test these models against, because I'm actually really excited that we have another competitor that not a lot of people are talking about. A lot of people right now are talking about O3 and DeepSeek, but Qwen actually has a model, 2.5 Max, that theoretically we should be pounding to see how it stacks up against these other ones. Till next time, guys, peace out.